To the 8085 assembly language programming. Today we'll be learning some instructions, arithmetic as well as logical instructions. So the first one is ANI 8-bit. So ANI is the full form is AND immediate, and this is a 2-byte instruction. It logically ANDs the contents of register A with the given 8-bit data. So whatever 8-bit data we are giving, it logically gets ANDed with the data which is in register A, and the result is stored in register A. Now, as in all the logical instructions, AC flag is set and carry flag is reset irrespective of the result, and all the other flags are modified according to the result. Now example is given here. If we write ANI 78H, so this will logically AND the contents of register A with 78 and the result is stored in A. Similarly ANI 1C, so in that case the data which is in A, it gets logically ANDed with 1C and the result gets stored in A. Similarly we have ORI 8-bit, so this is the full form is OR immediate. This is also 2-byte instruction. It logically ORs the contents of register A with the given 8-bit data and stores the result in register A. Okay, and even in this case AC flag is always set and carry is reset, and all the other flags are modified according to the result. Now examples are given ORI 78, so this will logically OR the contents of A with 78 and result gets stored in A. Similarly ORI A or 1C equal to A, so this is that particular which we saw in the previous example. Then similarly we have XRI 8-bit, so this is a XOR immediate. Now this is a 2-byte instruction. It logically XORs the contents of register A with the given 8-bit data and stores the result in register A. So by default, as we know, almost all the arithmetic logic operations has A as one of the operands, and even in this case AC is set, carry is reset, all the other flags are modified accordingly. The examples are XRI 78, so this will logically XOR A with 78, store in A. XRI 1C, it will logically XOR the contents of A with 1C and store the result in A. Then we see instruction ADI, so this is a arithmetic instruction. The three previous were all logical, this is arithmetic. So ADI 8-bit, ADI means add immediate. So this is a 2-byte instruction. It adds the contents of register A with the 8-bit data and stores the result in register A. All the flags are modified in this case. Like example ADI 15H, so this is A equal to A plus 15. ADI B3 is A equal to A plus B3 data, and the result is stored in register A. Similarly, we have the instruction SUI. So SUI is a subtract immediate. Okay, so this is a 2-byte instruction. It subtracts the contents of register A from the given 8-bit data and stores the result in register A, and all the flags are modified according to the result. So SUI 19H means A equal to A minus 90, SUI 19H is A equal to A minus 19, and SUI D3 is A equal to A minus D3. So this was regarding the explanation. Now let us see using the animation. Now let us see one animation. So here we have three instructions: MVI A45H, then ADI C7H, ORI E2. So I have just taken two instructions, one tutorial. Thanks for watching.